So in this second part to 11b, I want to show you some properties of integrals, and then I want to show you how to find out exactly what the original function was if you're antidifferentiating a derivative or if you're integrating a derivative. So first of all, let's look at some of the properties of integrals. Now the first property is probably the most commonly used one, and that's this one here, which basically says if you have a term or your function has a common factor, in this case it's k, a common factor for the function, the answer that you get when you integrate it is exactly the same as if you took the common factor out and integrated just the formula without the common factor. That's what that's saying there, and I'll show you that one in just a sec when we get down here. This second property, lots of the textbooks will often include this as a property, and this is just saying that if you have the integral of something that is made up of a number of terms, then you can actually find the integral of that thing by finding the integral of each particular term and then adding or subtracting as necessary. So if this was a plus between these two terms in the original question, your two integrals you would find separately and add together. Now you would have seen in the previous video I did this, separating it out and integrating each term one at a time, but I didn't actually write it out as one term at a time. Okay, so this, although they're listed in the book as being a property, is something that you don't really ever use. All right, so let's have a look at an example. So example number 1, we're going to integrate 4x squared. So this 4 is a constant, it's multiplying the whole of our function, and so what I can actually do is have that as being 4 times the integral of x squared dx, and then I perform my integration pattern on just my x squared and multiply the answer that I get for that by 4. And people are going to start getting upset now because I'm going to just say this is a little bit weird because it's supposed to be 4 times the whole of this thing, which it actually is. And when I multiply out this bracket, I get 4 times the first term, which gives me this term, and 4 times the constant. So this is just some constant. We don't know what this constant actually is, so it doesn't have a specific value. Okay, so this is just a variable. So when we multiply 4 times some unknown number, we still get an unknown constant. So we don't write 4c here, we just write c. Okay, we don't write 4c, we just write c. Because if c is a constant, let me say that again, I'll write it up here. If c is a constant, c is defining a constant, and you multiply a constant by c, or you multiply c by a constant, you still get a constant. And so that c is actually representing a constant, all right? So we just leave it as plus c. I hope I've kind of made that clear enough. It's a bit of a weird one, but just go with it. Just leave it as plus c. All right, so the next one, question 2, we've got the integral of 10x plus 5x squared. You can see that there's a common factor of 5 in that function, so I take the common factor of 5 out as a common factor, and then I can remove that to the front of the integral, and then I would go ahead and I would integrate both of those parts and then simply tidy it up by cancelling down anything that you can cancel, and finally multiplying through by 5 if you want to. It's perfectly fine to leave your answer at this level, but if you wanted to go through, remember it is just a plus c on the end. So one of the other things that you'll be asked to find is what they call the unique antiderivative, or what actually was the original function. So we know if we integrate 2x with respect to x, we get x squared plus c. Now, x squared plus c is actually a family of functions. So it's all of the possible parabolas with any plus c value like, and I've got just a few of them here. So how do we know which one of these functions is actually the correct function? Well, the only way we know is if they tell us some point that sits on the particular curve. If we know a point that sits on the curve, what we can then do is we can substitute that point on the curve into our formula for f of x plus c, and then find the actual curve, the actual original curve. So let's have a look at this example here. So if f dashed of x is equal to x squared plus 3x and f of 0 is 1. So you can see that they've actually given us a point on the curve. And the point on the curve that they've given us is in fact the point x is 0 and y is 1. So they've given us that point on the curve. So we can use that point on the curve. So to find f of x, what we need to do is we need to integrate. So we'll apply our integration formula. And then with our integration formula, what we then do is we substitute in our x and our y value. So the equation told us that f of 0 is equal to 1. So what we substitute in is our formula for f of x. So this is our formula for f of x. This is f of x with the plus c. That is f of x. So we make that equal to 1. And we substitute in our 0 for our x value. You can see I've done that there and there, equal to 1. We solve that and we find, that c is equal to 1. Move that out of the way. That c is equal to 1. So our original formula for f of x had a plus c in it. Now we know that c is 1. So as our final step, we're actually going to write out that our formula is x cubed divided by 3 plus 3x squared on 2 plus 1. That's our final answer. Okay, let's have a look at another way of asking that question. All right. The gradient of a tangent to a curve at the point x, y is given by 3x. So we've got some curve, we've got a tangent at a point, so we've got some curve. Let me just draw it over here. Got some curve here. At some point, there's a tangent. There's the tangent line there. Coordinates of this point are x and y. And the gradient of that tangent is given by 3x. So y equals 3x times x. Y equals mx plus some number. Okay, so the gradient of that tangent. Now we know that the gradient of a tangent to a curve is in fact just f dashed of x. The gradient of the tangent to a curve is f dashed of x. And our question tells us that the gradient of the tangent to the curve is given by 3x. So we've got f dashed of x is equal to 3x. And it tells us also that the curve itself passes through somewhere or other on the curve is another point, and it goes through the point 1, 3. Okay, so the point 1, 3 is on the curve. So what we're going to do to find the original equation, because that's what we're asked to do, the question says find the equation of the curve. So we're going to first of all integrate our derivative, And you can see that this time I've taken the common factor out. If you want to take the common factor out, take the common factor out. If you want to leave it in there and integrate, leave it in there and integrate. Doesn't really make any difference at all. You will end up with your integral being equal to x cubed plus 3. Now we know that this two pieces combined together is our formula for f of x. And so we know that the point 1, 3 is on the curve, so we know that when x is equal to 1, when x is equal to 1, f of 1, it's worth 3. The y value is 3. When you substitute 1 into the formula, you get an answer of 3, which is the y value. And so we're going to substitute those two values into our formula for f of x. So our y value goes in here. It's equal to 3. We substitute our x value into our formula, and we find 3 is equal to 1 plus c, so c is equal to 2. And then finally what we need to do is to substitute that back into our formula and write our final answer for the equation of the curve. And the equation of the curve is f of x is equal to x cubed plus 2.